All right, so today we're going to start on the next module, which is File I/O. It's pretty simple. It's pretty basic. For both languages, you have the exact same steps. You need to open the file, you need to process the file, and for that you need to determine whether or not you're doing file output, right? You're writing to a file, or you're doing file input. You're reading from a file. And then after you're done, of course, you close the file. Before that, though, what is a file? Well, a file is just a unit of stored memory. Usually when we think of a file, we think of a file on disk, on a hard drive or something, right? A text file or your source file or something like that. But what else is a file? Directories are files. Programs are files. Sockets, the thing that you connect to another computer with, you open up a socket and you write to that socket to send communications over to another computer over a network. That computer sends back communications through another socket. You read from that socket. How does data get back and forth between two computers? It's through files, right? Or buffers. Usually files are stored on disk for long-term persistence of data. So there's a new nice key word there, persistence. When we say that we want to save something, we're persisting it across different program runs. Because a program, is ephemeral. It's really, really quick. Right? A program should only run maybe a couple of seconds, at least the programs that we're writing for this course. At most a couple of nanoseconds or something. But if you want data to persist, to live past your program onto the next execution of another program, you need to save that data somehow. And again, input is going to be reading from a file, output is going to be writing to a file. Files themselves can either be plain text or binary. Right? They could be plain text, but not even intended for human consumption. For example, we've seen examples like XML and JSON data or base64 encoding, where you are taking binary data and translating it to a bunch of capitals, A through Z, lowercase and uppercase, 0 through 9, and then a couple more string characters, so that you can send it, say, over email. Binary data is not actually sent over email. If you have an image that you send to somebody through email, that is encoded in base64. In other words, it's converted to a bunch of characters, sent over through email, and then you receive that text, and then your email client or whatever is responsible for it decodes that into an actual image file. We're not going to deal directly with binary files. Maybe on Wednesday I'll show you a demonstration. But if you're going to be dealing with binary files, 99 times out of 100, you need to bring in a library to do it. For example, images. You've dealt with images now several times. We provided a library to do that for you, or it was built in the case of Java. You don't want to go mucking with low-level stuff like that if you don't have to. So we're going to stick with plain text data, maybe sometimes data interchange formats like XML, JSON, or whatever. But we're going to follow the same three basic steps. You open the file, you process the file. Once you are done, you close the file. Failure to close the file may lead to file corruption. Right? 99 times out of 100, it doesn't. The operating system saves you from yourself. But it's that one time out of 100 that you end up corrupting it. Oops, I should have closed the file. Right? All right, so let's take a look at file I/O in C. In C, files are represented by pointers called handles, right? A file handle, and that's a type that's built into the standard input-output library, file star. Right? Let me give myself some more room here. Right? So to open a file, you use fopen, which stands for file open, and provide two parameters: a string representing the path/name of the file you want to open, right? And the second one is a string representing the mode. Do you want to open this file for reading or writing? All right, there are a couple of other modes that are supported, but we won't look into them. We're just going to keep it simple. You can either be, say, R for reading, or you can be W for writing. And writing is going to be output. Reading, of course, is input. Okay? If successful, it returns a pointer that points to the beginning of the file. Right? So if I've got my file here and there are 5 lines in that file or something like that, right? Then when I open it, I've got that pointer that's pointing to the first character in the first line. As I start reading the file, either character by character or line by line, right, that pointer then advances and advances automatically for me. That's why we call it sometimes call them handles. It handles the advancement of the pointer for you. Okay. If unsuccessful, what do you think happens? If it returns a file star, a pointer, right? What's the only thing that it can return in order to indicate something went wrong? Like the file doesn't exist, or you don't have permission for that file, etc. Right? It doesn't exist, you don't have permission, so it returns null. Right? And you can check for that. Let's go ahead and come over here to our coding environment, and let's go ahead and try to open up a file. All right, so I need a file, all right, star, and let's go ahead and just go with input. I'll just call my pointer input, and I'll call fopen. Now, I'm going to go ahead and open a file called myfile.txt. Right? And let's open it up for reading initially. Okay? Now, do you see a file over here in this current working directory called myfile? Nope. So, what do you think is going to happen? If input is equal to null, I can check for that. Printf, cannot open file, end the line. Otherwise, else, printf, opened successfully. There we go. Which one do you think is going to happen? I want to open it up for reading. It doesn't exist. Do you think that that's an error condition or not? Let's find out. There we go. A.out. Cannot open file. Why? It doesn't exist. All right. So if it doesn't exist, it will return null. Fine, let's go ahead and open it up for writing instead. We're going to output this file. Now, do you think that this is an error condition? A.out. Open successfully. Let me come over here and refresh, and you'll see that myfile.txt has been created with nothing in it. Right? So in other words, if you open it for reading and it doesn't exist, that's an error. If you open it up for writing, well, it doesn't matter if it doesn't exist or not. It'll create it for you because you're going to write to it. Okay? So let me go ahead and put a bunch of stuff into this file. Hello, how are you? I'm fine. 1, 2, 3, 4. Okay? I've saved that. Let's come back over here and rerun the file now. Right? So first of all, what am I not doing? I'm not processing. I'm not doing the second 2 steps. Right? I've opened the file. I haven't done anything with it, right? That's the second step of actually processing it. And I haven't closed it. So let's go ahead and close it. Close the file, right? For close. And I just simply pass in input, okay? I still haven't processed it. All I've done is open the file and I've closed the file. Now, what would you expect the behavior of this to be? Remember, my file over here contains at least 5 lines. So let's go ahead and run this. Opened it successfully. It successfully closed it. The program is done running. I'm going to close this, and let's open it again. Uh-oh. What happened to the contents of my file? All gone, right? There is no undelete. There is no undo, right? This is lower level programming stuff, right? There's no recycling bin. What is it in Windows? Is it the garbage or I guess it's trash in iOS, and it's a recycling bin in Windows, right? You can't go in there and undelete the file or anything like that. It is gone, right? Goodbye, right? So if you are going to open up a file for reading, you'd better make sure that you're not overwriting anything that you don't want. What happens is there's stuff in there already, 5 lines of whatever. You open it up with the pointer initially at the beginning of the file. You don't do anything. You close it. Well, that's it, right? That's the contents of the file, nothing, okay? So let's actually go ahead and process it. Process the output file by giving it some output, ... So let me go ahead and create some variables here. Int x is equal to 42, double pi is equal to 3.14159, right, there we go. And I don't know, a string here. I don't know, school, right, equals school of computing, Right, there we go, with an exclamation point. Now, how do I print stuff to the standard, to a file? Printf, if I use printf, right, that's going to print stuff to the standard output. It's going to look something like this. X is equal to %d, pi is equal to %f, and name is equal to %s and the line, where I'm going to print out X, pi, and school. Right? In fact, let's go ahead and put in n-line characters right here instead of commas. N-line character, n-line character, okay? Now, I'm going to go ahead and compile this and run this, and you'll see that that print statement successfully printed to the standard output. If you want to print to a file, all you have to do is use fprintf instead. Right? So everything that you know about printf, right? All of the placeholders, all of the formatting tricks, everything like that, cut, paste all that knowledge for fprintf right here. Right? You can put in tabs, you can put in whatever you want. The big difference is that you actually have to tell it what file you want to print to, what file handle you want it to print to, okay? Now let's go ahead and compile this again, run it, and you'll see that it no longer prints out to the standard output. Instead, it's all over here in myfile.txt now. Right? So everything that you know about printf applies equally well to fprintf. And that other one that we looked at was with respect to strings, sprintf. Right, where you can print to a string instead. Okay, that's file output. It's that simple. There's really nothing else to it. Right? Question? Yeah, go ahead.
Can you open the file if it's like inside of a folder?
Good question. So let me go ahead and give this as a demo over here, just to make sure that I'm not losing the code. There you go. It's in your notes. All right. So let's come back over here and let's change this so that, I don't know, let's go ahead and create a folder within this, new folder, test. All right. So if I wanted to open up that other file, test/yes, right? So in other words, again, the first argument here is, where is it? The first argument is a string representing the path and the name of the file that you want. So if you want, say, the current working directory / the directory called test, and then under that, the file called myfile.txt, then you would use a relative path like this. If you wanted to go up one, maybe up two directories, .. /.. right? Then that's up two directories, down in, let's go ahead and list, hopefully it's there. It should be there. Let's see, pass. There we go. There's a file called etsy, etc. passwd. What do you think passwd stands for? The password file. Now, should I be able to read that file? Well, if it can actually contain passwords, then I probably shouldn't, right? But it doesn't just contain passwords. It contains redacted passwords, right? This X here, it used to be that they did store passwords there, but they no longer do that because this is a world-readable file. But do you think I should be able to write to it? Absolutely not, right? So let's take all this stuff out here and see if it opens successfully or not. Out. Right. Cannot open file for the purposes of writing to it. I can open it up for the purposes of reading it because there's no problem. There's not any real passwords that are stored in there. Open successfully. I can start processing that file line by line if I want to. Now, the real passwords are stored in the Etsy shadow file. There we go. Should I be able to read that? Absolutely not. I think I can because I'm root, or at least I have root access. Etsy shadow. Ooh, sudo more Etsy, sorry, shadow. Right, there we go. There we go. And you'll see that they're still redacted. They're not even stored there anymore. I wonder what else is in Etsy. I'd have to find shadow. I don't even see it here. ls Etsy sh. No, there it is. Shells. Oh, maybe it's in this one. More Etsy shadow. That thing. Yeah. Let's find out. Sudo. Nope, that's not it either. That's probably just a backup or something. So on most systems now, they're in an encrypted file somewhere that nobody has access to unless you are actually root. And I'm not root. Who am I? I'm Ubuntu, I think. Yep. Okay. So this is an absolute file path, right? Starting from the root file system, under the directory called etc, find a file called passwd. Note here that it doesn't have a .txt extension, does it? Extensions are just a convenience thing, right? Now in Windows, they have meaning, because if you don't have a .txt, Windows doesn't treat this as an actual text file. But that's from a consumer point of view, right? You don't have to have any extensions at all in a real Unix system or a Unix-based system. It's just a hint as to what it is, okay? All right, so that's file input, or file output, I should say. What about now? Let's go ahead and yeah, we'll stick with the etc password file here. We will be able to open that up successfully for reading. Now let's actually read it. Right? So there are two ways to do this in C. So file input in C. Right? Two ways. In fact, there are dozens of ways. I'm going to show you two ways that are the easiest and the safest. There are several different ways that are very, very dangerous because you risk what's called a buffer overflow. Right? So two ways. You can read line by line or character by character. Right? So the ways that you do this is with line by line, you use fgetS. Right? And character by character, you get fgetC. So guess what these stand for? fgetS is file get string, right? You want an entire line, which is a string of characters. Character by character, fget character, right? Pretty easy. So let's go ahead and do it over here with this. In fact, let me change this so that it's just so I have some control over it. I will open up my file, or .txt. Remember the contents of this file? It's got all this stuff right here. I'll add some other stuff to it. Hello world. Hello world. There we go. Okay. Remember that it has 4 lines, and each of those 4 lines has a certain number of characters. So let's do it character by character first. So char, C, is equal to fgetC. All you have to do is tell it the input file that you want to read from, right? And let's go ahead and print that out. Printf C is equal to %C and the line, oops, and C. Right. Let's do that twice. Of course, I'll reuse that same character here. Let's do it thrice. 4 times, 5 times. There we go. So this should print out the first 5 characters in that file. Come on. Get that up. Just type it. X space equals space 4. Check out. Right? X space equals space 4. Right? Okay. I don't want to have to keep doing this over and over and over again. So what I'm going to do is I'm going to put this into a loop. Now, what kind of a loop would be most appropriate here? A for loop or a while loop? Now, generally the guideline of use one or the other loop, you use a for loop if you know exactly how many iterations you're going to go over. You use a while loop if you don't know. So do I know how many characters are in that file right now? Not until I've read them all, right? So let's go ahead and go into a while loop. While you are not at the end of the file, we'll come back and fix this. Then I will print out the character and read the next character. Okay? So how do I know when I'm done? Yeah. The null terminating character would make sense for a string. Unfortunately, that's not the case for a file. Instead, there's this very special character that you will not find in the ASCII text table, that it is a C thing only, EOF. Oops, EOF. EOF stands for end of file, right? So at least it's straightforward, right? While you are not at the end of the file, right, there's just this special character that fgetC returns. It's not actually in the file, by the way, right? You will not find that character in here because you will not find it in the ASCII text table. ASCII, right? ASCIItable.com. Look as hard as you want. You will not find this character in here. The reason is because the EOF character, it actually has an ASCII text value of -1. it starts at 0. Right? So it's one of those cases where you have this special flag value, -1, that is not a valid value. Instead, it is a flag value indicating that something else happened, that you're at the end of the file. So while you're not at the end of the file, read the next character, read the next character, read the next character. Right? It's not that big of a file, so let's go ahead and just output the entire file here. There we go. So you see that x equals 42, pi equals blah, 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 all the way to the end. Hello world, and the very last character was that exclamation point on the last line. Right? And I know that I'm at the end of the file because I've got EOF. Right? So character by character. Right? I'll go ahead and put that into your notes here, and then I'm going to erase it and do it another way. Okay? So now I want to read it line by line. Okay? In other words, I'm just going to have 4 iterations for the first line, the second line, the third line, and the fourth line. Same problem though. Do I know, if I didn't know how many characters there were, do I know how many lines are in the file? No. Another thing to note here, predict how many end-line characters are actually in this file. There's an end-line character on the first one to go down to the second line. 2, 3. Is there an end-line character at the last line? Well, is there a 5th line? So no, there are only 3 end-line characters. Now there are 4 end-line characters and 5 lines, but the 5th line is blank. So you have to be careful at the end of files. Right? Let's take a look at that, what it looks like when you do this line by line. First of all, what I need is a buffer, char buffer. And I'm just going to make it big enough here to hold any line that's up to 999 characters long. Why 999 characters if I have 1,000 here? It's a string, so what do I need at the end of a string? The null terminating character. Right? So this will break if I have a file with very long lines, right? Something with more than 999 characters. Okay. But what I'm going to do is I'm going to use this buffer, and this is going to store the elements line by line. I'm going to read the first line and put that into the buffer. I'm going to read the second line and put that into the buffer. I'm going to read the third line and put that into the buffer, etc. Right? The way that I'm going to do that is using fget s. And again, it stands for file get string. The format of this is that you need to provide it 3 arguments. The file, or actually, sorry, the order is the string that you're going to read into, the maximum number of bytes that you want to read into, because of course the buffer only has 1,000 characters in it. So in other words, the size of your buffer needs to match this argument right here. Right? And then finally, the input file that you're going to read from. Okay? This too returns a value. It returns a string pointer. And I'll just go ahead and put it like, I'll call it line for now. Right? We're going to need that though. And we'll talk about why we need that in a moment here. But let's go ahead and finish off this line. %s and the line, and line. There we go. Let's do that 1, 2, 3 times. Of course, I can't have multiple declarations of that variable, so we'll go ahead and do it 3 times. Now, I'm not reading the entire file. I'm only reading the first 3 lines, which again are that x, pi, and name. Okay? Let's go ahead and compile this and run it. Line is equal to x equals to 42, then a blank line for some reason, pi, and then name. Why are we getting double-spaced output here? What do you think? Well, I told you that there was an end-line character where? Right here. Right? That's why we're going down to the next line. So, when we read that entire line, what happens to that end-line character? It's retained in the buffer. So when I actually print it out, I've got 2 end-line characters. One in the original line of the file, and one right here, me printing it. Right? I could take that out, or an alternative would be to chomp it out. Right? So what I'm going to do is I'm going to chomp, that is, remove the end-line character from input. How do I go about doing that? I want to make the last index of buffer equal to the null terminating character, right? Right now it is an n-line character, right? And I want to change that, chomp it out and remove it and make it into a null terminating character instead. So what's the last index of buffer? If I've got a string, how do I determine what, hello, H-E-L-L-O, how do I get that last index? String length gives me 5 of buffer. But is that the last index? 0, 1, 2, 3, 4? Nope. So, -1. And if you do that over and over and over again, and after you read each line, there we go. Now I'm not going to have that double space issue anymore. Right? I've chomped it out. Let's go ahead and get rid of all of this and put it in one copy of it into the while block right here, right? So while you are not at the end of the file, ... I will go ahead and remove the n-line character, print it out, and then get the next line here. Now, with fgetC, right, I was getting a character. EOF is a character that tells me that I'm at the end of the file. Unfortunately here, I'm getting an entire line, an entire string, and a string cannot be equal to EOF. EOF is a character, a special character. So what I need to do here is I need to do it with respect to line. What do you think fgets returns when it reaches the end of the file? So it reads the first line, the second line, the third line, the fourth line. Oh, now it's at the end of the file. Is there anything to process? No. So what's the only thing that I can give back because I'm returning a pointer? Null. While line is not equal to null, continue processing the file. GCC, run it. There we go. X, pi, name, hello world. Uh-oh, what happened to my exclamation point? Remember, there's an exclamation point after world. What did I do? I chomped it out, right? What was I thinking was at the end of that line in line 4? An n-line character that I wanted to get rid of. But was there an n-line character? Nope. Now there's an n-line character, right? And 5 lines. But originally there wasn't. So what should I probably be doing here instead of just blindly removing the last character from the input? Probably checking it. If this is an n-line character, and how do we get the n-line character? /n. If that's an n-line character, then go ahead and get rid of it. Otherwise, leave it in there because it's part of my data and I want to process it. Now it's retained. All right. Cool. Line by line. It breaks if you've got a file that's more than 1,000 lines. Right? And you can have that. Right? I'm not going to sit here and type. Instead, I'm going to paste, 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 paste. I don't even know how many that is. Word count, character, my file. All right, that's certainly more than 1,000 here. I'll just go ahead and bump it up even more. There we go. All right, there we go. All right, it's going to probably break here. Okay, there's line. X is equal to, nope, it didn't break. But it didn't treat that as an entire line, did it? It read the first 999 characters of that line, which is going to be whatever this is, right, all the way down to this right here. And then it went to, the next time I called it, it got the rest of the line, and then a line character. So the takeaway here is, if you want an entire line treated as one, then you need to make sure that this is big enough to hold whatever line you want. Or that you're only dealing with short line files. Or that you realize that, well, okay, some lines will be broken up. Because fgets is only going to read at most 999 characters. Why only 999 again? Null terminating character. It puts it in there automatically for you. Right? And anything else, it has to break up those long lines. Okay? Otherwise, it's going to work pretty much like this. Right? Okay? All right. So make sure that you've got this over here, and we might retread. F get CS demo. C, there we go. Any questions so far? Otherwise, output, super easy, right? Input, okay, a little bit hard, right? But there, if you keep it simple, you should be good. Right? We'll take a look at Java really quick, and then we might retread some of these details. Okay. Guess what? Java defines a file, right? And you can do it very similar to Fopen. You can create new files, like create a file, new file in the current working directory, a file called file.txt. You can use an absolute path to a particular file. You can use a relative path up to levels, then down the archive, and then the file.txt in it. Now, those files don't actually open anything. That's just creating a resource that says, there's this thing called a file, and it's located somewhere here. To actually open it, you need, for whatever purposes you want to open it. Let's go ahead and go with file input first of all. The easiest way to do this is through a scanner. Now, we've used a scanner before, remember? What did we use a scanner for? When we typed in stuff on the keyboard, right, the standard input, we did something like, let me get rid of all this stuff. We did something like scanner s is equal to new scanner, but we gave it what? System.in. I want you to read from the standard input, right? The system input. Let's import that. Java.utils. Right? And so that you can say int x is equal to s dot next int, right? And then system.out println iRead a x, whatever x was. Right? So let's run this and review what it looks like. Now, you'll see here it's running and it's waiting for me to mash the keyboard and type something. 42. Hey, it's green. What does green tell you? That's the standard input. Black is the standard output, and red is the standard error. Right? There, I read a 42. Right? Well, a scanner, what is a scanner scanning? It's scanning the standard input. What do you think the standard input is? A file. Right? So all I need to do is change the scanner so that you're not reading from the standard input. Instead, you're reading from whatever file I want you to read from. File f is equal to new file. I'll put it in the data directory here, foo.txt, let's say. Right. Now, in Java, at least in Eclipse, everything is going to be relative with respect to the project. So if you want to have a bunch of input files, it's best to create a data folder, and then within that, create a new file called foo.txt. There we go. I'm just going to steal this over here. Well, not all that. I don't want all that. Oh, no. Okay, I'll go ahead and do all that. There we go. All right. And let's go ahead and import this. And we'll be reading from this file instead. Okay. Now, it's not going to like this because, remember when we covered error handling, and I told you that there were two types of exceptions in Java, checked exceptions and unchecked exceptions. Unchecked exceptions are the ones that could happen, and then you can choose to whether or not to handle them or not, and how to handle them. This, unfortunately, is a checked exception. I am forced to surround this with a try-catch. Right? If the file is not found, something will happen, and then we'll print a stack trace here. Okay. In fact, let's show what happens here. I'll change it to bar. Remember, there's no bar file here yet. So when I run this, it's going to result in the exception and the stack trace here. There is no such file, data bar.txt. Right? But there is a file called foo.txt. Right? All right, so let's go ahead and read in each line. Read in a line. So a line is just simply going to be a string. S dot next. That's it. Next line, sorry. And let's print it out. System.out.println line Yeah, well, I'll just print out the line, no formatting here whatsoever. Right? Do it again, again. Right? Of course, I can't have two variables named line, so I'll get rid of those redeclarations. There we go. It'll compile. Let's run it. Right? There we go. There are the first 3 lines. Did I have to worry about a buffer size of 1,000? Nope. It took care of everything for me. Why? Because there's no memory management in Java. A string can be as big as you want it to be. If the file has 1,000,000 characters in the first line, it'll take care of all those 1,000,000 characters, put them into a string, and you're good to go. Right? Now, what happens when you get to the end? Let's read the last line. Still good. Let's read one more line. Is there a fifth line to read from that file? Nope. So, no line found. Right? How do I prevent such a situation? Well, first of all, you don't copy pasta. Instead, you put it into another while loop. While the scanner has next line. Right? Then go ahead and read the next line. Print it out and do whatever you're going to do. Okay? Now this one will read all the way to the end of the file and then break out of that while loop once it's done. That's it. Careful. What were the 3 steps to file I/O again? You open the file. You process the file. You close the file. Right? So we did that in C using, I thought we did, hopefully. I erased it, but I shouldn't have, for close input. Right? I showed that at one point though, right? Okay. Over here in Java, well, Java takes care of everything for you, right? Again, 99.9% of the time, yes. It's that 1% of the, that 0.001% of the time that it doesn't, and you're left wondering what the hell happened. Right? So let's go ahead and close it. We're going to close the scanner. s.close. Right? Again, some of the time it's gonna, most of the time it's gonna close it for you, right? But sometimes it won't. In which case, it'll corrupt the file. Right? Make sure that you're doing it explicitly here. Okay. All right. So you open it, create a new scanner, reading from a file, which you have to surround with a try catch because this is a checked exception, file not found exception. Get rid of the to-dos. The best way to handle this is not to print the stack trace. The best way to handle this is to catch and release, right? All those fish. So throw a new runtime exception, an unchecked exception, wrap up E in it, and then just simply throw it again. Right? And again, the way that that will work is, oops, come on, save it. It'll end up with the same stack trace here, no such file or directory, but now I'm just simply rethrowing it. Okay? Let's go back to foo. By the way, can you read character by character? Yeah, if you really want to. S dot next char, or no, not next char dot, what is it, next byte? Next, you can get next integers, you can get the next byte, the next float, the next double, the next integer, right? Dot, 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 whatever you're gonna do. But I find it just handy to read an entire line and process that line. Right? This is probably the easiest way of doing file input. Okay? In Java, at least. All right. So file input scanner, use a file, right? And use the scanner to read it line by line, right? Java, there. Okay. Any questions on file input? No? Then file output. Again, there are a dozen ways of doing this. I'm going to keep it simple, right? I'm going to show you using PrintWriter for the same reason that I showed you fprintf, because everything that you've done up to this point as far as formatting in Java, like system.out.println, system.out.print, system.out.printf, all 3 of those are equally valid in a PrintWriter. Why? Because a PrintWriter is a file. And guess what? System.out.println, what are you doing? System.out, system.out, system.out. What is that thing? That's the standard output. What do you think the standard output is? a file. Right? Everything is a file, right? Once you realize that, then everything becomes way simpler because you already know how to write to the standard output and read from the standard input. All you have to do is copy paste that knowledge. Right? So a print writer allows you to use the three things that you've used before. Printf, or print, println, printf methods. So let's go ahead and come back over here, and this will be file output. So let me go ahead, I'll go ahead and get rid of, well here, I'll just start up here. Remember there is no bar file, so I'll go ahead and open that up, but I'm not going to read it, so it's not going to be a scanner. Instead, what I'm going to do is I'm going to create a print writer. PW is good enough, new print writer. Right? Wrap it up in that file. Right? Print writer, import that. There we go. Get rid of all this stuff. Okay. Now that I've got that open, I can do whatever I want. pw.print. Hello. No end line. There we go. pw.println. ... Now we have an end line. There we go. pw.printf. Right. I'm going to steal everything that I did over here. Oh, did I not have anything? Oh, I got rid of all of it. Okay, then I'm going to have to steal it from over here. There we go. I'm going to steal all this stuff right here and put it up here. And I can't have a character array. Instead, it's going to be string school. There we go. Why are you... There we go. And same as before. Oh, I also want to steal my formatting. There we go. Steal all of this stuff. Put it over here. And done. All right. Now, run this. It's all just happy. Now, careful. Do you see a bar file over here yet? No. Remember, over here in your CS50 ID, every so often, you have to come up here and press this refresh button in order to see a new file. Same thing in Eclipse. What I have to do is I have to come over here and right-click my project and refresh it. Hey, there's the bar file. Right. Double-click that, and uh-oh, nothing was there. Right. So remember, it's that 99.9% of the time that everything is taken care of for you. We just hit that 0.1% of the time. Right? What did I not do? I didn't close the file. pw.close. Let's run that again. And now, all is right with the world. All right? So don't forget the 3 steps. Open the file. If you don't do that one, you're dead in the water anyway. Process the file, whatever you're going to do, right? And then finally, close the file. Right? Lack of closing the file here means that that it didn't actually get flushed out to the from the buffer. Right? Goodbye. There we go. What if I ran this again? What about all of that data? I want to keep that data. I want to keep all this data. Right? But I'm going to start writing to the file. Right? I'm going to go ahead and get rid of this. Right? Run it again. Come over here. Uh-oh. Bye-bye data. Right? You overwrote all your data. Why? Because every time you start a file, that pointer, that reference, starts at the beginning of the file, first line, first character. Both languages, every language is like this. Okay? There are also other convenience functions here. Oh, I don't have it here. Let me go ahead and undo that. And I will go ahead and put this into the notes, and then I'm going to show you something cool. Right? You can do this in a one-liner, Java. There we go. And now I'm going to have to look it up. I want the entire contents of foo. Java read entire file, one-liner. Java NIO library. There's this Java NIO library. The NIO stands for non-blocking input-output. And where is it? Read lines. Is it read lines? Yeah, whatever. Read all lines. There it is. So let me go ahead and cut and paste this code. And let's try it out. There you go. Import java.nio.file, java.nio.file, paths, and not that thing, but what is it? Data.bar or foo.txt. There we go. Read all lines. Okay, fine. We'll do it this way. String. I'll call it lines instead. That's better. Whoever wrote this code is terrible, style-wise. There we go. And yeah, get rid of that. There we go. Import this. Actually, is this a caught exception? Probably not. Let's find out. Oh, it is. I'm gonna have to surround this with a try catch. Still didn't get away from it. How do I deal with it? I throw a new runtime exception E. There we go. All good. There we go. One-liner. How did I get all the lines? Just this file NIO library. System.out.println lines. There we go. Print them all out and see what happens. Okay, let's get rid of that first line. I'll make it like that instead. There we go. There. The first line was x is equal to 422 blah 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 blah. The second line, third line, fourth line. Or actually, the third line. There are only 3 lines, right? 4 lines. And yep, there we go. Excellent. So I've reduced at least part of your hack now here down to 1 line, right? See if you can do the other part of your hack down in 1 line, right? And use something like this. Now you'll note here that what happens to that end-line character though? Is it retaining that end-line character? If it retained that end-line character, you'd expect the rest of this stuff to be on the next line, next line, next line. So what does that tell you about this solution right here? And what does it tell you about our solution over here to read each one of these lines? The end-line character is not retained. Right? So that's one difference between the 2 languages. In Java, the tools that I've shown you so far, they do not retain the end-line characters. In C, fgetS and fgetC will retain the end-line characters. You have to take care of those if you don't want those. Okay? But you know how to do that already from your hack this week. Right? Remove char. Right? You can remove a end-line character from the entire string. Okay? All right, any questions? No? Then we'll continue this next time with maybe some exercises or something like that. But on Wednesday, remember that we have that department SAB student advisory panel SAP. So you can come up and get let's see. On Wednesday at 11 o'clock is when it starts, and it's on the 3rd floor. So I invite everybody to come and check it out. And even if you don't want to say anything, you can at least get some pizza if you want. All right. I'll remind you about it on Wednesday, though.